Good and comfortable. Good morning, everybody. Welcome to another wonderful morning of Chem 1105 with your host, me, Dr. White. Hi, everybody. All right, first of all, I need to apologize to you. A couple things I did yesterday. I was rushing and I shouldn't rush, and I know better. It's been about almost 2 years since I've had a smaller 50-minute lecture. I'm used to either a 2-hour or a 3-hour lecture, but I'll get it down today and tomorrow. Another thing, I made a mistake, which is why I'm apologizing. I talked about the method I developed, how to eliminate test anxiety. And I said after class on Friday, I would teach that. That's wrong. Bad, Dr. White. Everybody know what that means? I have a couple of students 2 semesters ago from outside the United States. They were born and raised, and they didn't know that means bad. When you're a kid, shame on you. They still do that. But anyways, where I made a mistake was, no, I shouldn't ever say I'll do something after class, because you may have to get to another class. So what I will be doing is next Tuesday in lab, I will teach the method how to eliminate test anxiety. And I'll do it at the end of the lab. If you want to leave early, you can. If you don't and you want to stick around, you can too. And that way I won't be doing something wrong, which I try not to. After class yesterday, one of your colleagues had some questions, which I answered. All questions are good questions in my class. Remember, there's no such thing as a dumb question. My class in my universe, period. But feel free to ask questions. If I zoom too fast over something, say, could you go back and explain it? And the answer will always be yes. I've taught this enough times that the way I have it scheduled, there's plenty of time for questions and for me to go back and do things. Look at. Okay, now on Tuesdays, we'll be having what's called discussion in lab. But this semester, the gods have frowned upon me a little, and really you, where we're going to lose a lot of time due to Labor Day, due to what's called in-service day, and finally due to what's called Thanksgiving holiday. So I'm going to be making that up in the lab, this lab, next lab, and the one after that, where normally what I would do is first part of lab, we go through a problem set, which usually takes about 45 minutes. We'll take a 5-minute break normally, and then I'll do the lab. And most labs will be out of here, meaning you, by 10:30, even though we're supposed to go to 10 to 12. But part of that is one, blackberry tea from Republica Tea, really good. But anyways, part of that is because I know how to teach the labs. And the other part why we're getting out, you're getting out early, is you'll be doing lab simulations. All right, now today I'm going to do something a little different. I'm going to do the lab first, and then I'm going to lecture for a while to make up for the time we'll be losing. Now, I could have just said, heck, I'll just rush and what the heck, but this way you'll do better on the test, which makes me happy and hopefully makes you happy. All right, let's get into the lab first. Let's talk about the syllabus, which I need to open, which I forgot to do. All right, thumbs up, people. Do you see Chem 1105 syllabus on your? Thank you. All right, let's go through this. This semester, you'll be doing labs, and labs count for about 23% of your grade. And labs, or 24%. It's based on lab reports and attendance. Well, online, I don't really do that. And performance, in other words, you do the labs right. Each lab is worth 10 points. We're going to have 14 labs, but I take the top 13 out of the 14 to calculate your total. It's the sum of the top 13 labs. Now, lab reports are due the next lab session after lab for which the report is being handed in. So in other words, today's lab is due by next Tuesday. You get 0 points for a lab if the lab report isn't handed in. Since it's 10 points, you don't hand in a lot of labs, you're going to lose a lot of points, which will not help your grade. You'll get 0 points for a lab that's more than 2 days late. So today we're going to do a safety lab. It's due next Tuesday. If by next Thursday you don't have it handed in, you'll get 0 points. The reason I do this is I don't need 50, 60, 100 labs to grade the last week of the semester. That happened many years ago until I put this in. All right, now, here's the tentative schedule. This is the date, this is the lab. And each of these labs you will be given. You don't have to buy a lab book. All right, if we log into Blackboard, everybody see announcements on their screen? Thumbs up, people, thank you, or shake your head up and down, people. I appreciate it. If you look on the left, under announcements, you'll see assignments. If you click on that, you'll see different assignments. Don't forget to hand in your lab sheet. Now, let me go to student view. Click on assignments, and this is what you would see. And if you click on lab safety, you'll see the assignment, the due date, how many points. Now, for the lab, I have both the safety lab in a Word document and a PDF, whichever you like to use, you can. Now, if you don't have a printer, relax. You can just handwrite out the data in different tables if there's a table in the lab. And at the end of all labs, I have some questions for you to answer. My lab write-ups are quite simple. I don't ask you to do a pre-lab or anything like that ever. And you'd upload it by attaching the browse your computer and then upload it. Or I guess cloud service too. I stay away from cloud service. That's my personal thing. And you submit it. And if we go on the bottom here, you'll see a button here, black submit. And I have it set up, you can submit it more than one time. And that's how you get the labs. Now, one thing I should mention, if you downloaded the lab from the labs I just showed you, either one, before 7:30, 8 o'clock this morning, go back and re-download it, because the first video, which I changed, I didn't realize it. I thought they had taken it off YouTube, and obviously I found they didn't, is what's called the American Chemical Society, or ACS video, which you should use. All right. If you ever have any questions, how to do Blackboard, how to do anything I show you, remember, ask, or you can also come to my office hour, which is tomorrow, and ask, or after lab today, and ask. All right, let's have lab time. Remember, normally we do a discussion, then lab, but today I want to do lab first. I can do that, I'm the teacher. Uh-oh, it's obnoxious Tuesday morning. Now, if you open the lab, safety lab, I assume everybody can see lab 1, safety lab on your screen. If not, scream at me or say something. This is the lab you're going to be doing. And where it says personal equipment, the ACS lab video here has a lot more. I will expect you to watch that on your own. This is probably one of the longer labs because that video is about 40 minutes long. But important things in that video are, what's the most important thing? Wearing goggles. A couple of years ago, COD initiated some changes. Everybody has to wear goggles. You can see mine, it says COD on top. At the other school, they give it to us. They have them there. But anyways, everybody has to wear these in a lab. We're not going to be in a lab, but I still want to teach you this. This is the most important piece of equipment, period. If something happens to your eyes, they can't be replaced, at least not that I know of today. And when I was in grad school, a colleague of mine, another lab, had something blow up in his face. He was rushed, was doing something very dangerous that he'd done before, but he rushed it. It blew up. Luckily, he had safety goggles. And I was with his wife in the emergency room. A couple hours later, the surgeon came out and told us, your husband, actually the wife, I was sitting next to him, or his wife, your husband is very lucky. If he hadn't had his safety goggles on, I'd be telling you he's blind now. And that really, how should I say, impressed me. Always protect your eyes. So your safety goggles are your most important protection. Even these aren't as safe as safety goggles. All right, now at COD, if we were face to face, another thing that's a requirement they put in place a number of years ago is all students and faculty have to wear gloves. We provide them. Obviously, we're going to do a simulation, so you don't need to put on goggles because I don't think your computer screen is going to hurt. Do something, spray chemicals at you. I hope not. And you don't have to wear gloves, but I'm teaching you this stuff. So the safety equipment on behavior and all that, this you can skip because it's all in that first video. Same thing with burner safety. Now, when we look at a chemical in a bottle or on a truck or other things, a tank wagon, they're different hazard symbols. And here they are. And I'd ask you just look at them and just review them on your own. Now, one of the most important things when dealing with a chemical is called the Material Safety Data Sheet, MSDS. And I'll usually just call it the MSDS sheet, which really I don't have to say the word sheet, but I do. MSDS sheet tells you about, and sometimes called the SDS sheet, about hazards of a chemical. Every chemical that's manufactured in the United States has a MSDS sheet associated with it. In fact, some of the chemicals I invented at companies I've worked at, I've had to write and help write the MSDS, so I know about them quite well. And the good thing is, after my class, you might want to look up MSDS sheets for things that are ingredients and things you buy from the ingredients label to see if, do I really want to buy that stuff? Is it that hazardous or maybe it's not? And an MSDS sheet will show you that. Now, how do you find the MSDS sheet for a chemical? Well, go to Google. All right, everybody see Google on the screen? And if you want to find a MSDS of a certain compound, hold on. You didn't see it. Now you should see Google. Let's do type in sodium hydroxide and then type in the letters MS, DS, enter, and you'll see for different companies, the MSDS. Now, I know Fisher Scientific is a reputable company, so I'll click on this, and here's the MSDS. Now, some of these are a little older, and they'll have usually the chemical product composition is 100% of most sodium hydroxide, emergency measures, firefighting, and things like this. Now, this is an older one. Now, this doesn't have the symbols. I picked one that's old. But if you look at some of the MSDS sheets, I'll be having you look up, you'll see what's called the NFPA symbol, this diamond. And blue is for health hazard. Red is fire. Yellow is reactivity, like won't react with waters. And white is any special hazard. Now, if there's a number in there that tells that kind of hazard exists, it goes from 0 to 4. The higher the number, the more hazardous it is. So 4 is high. So if you saw 3 or 4, that's something you'd be pretty careful around. If you see no number or 1, well, it's not that bad. And this you should know. Now, a couple things on here, if we were face to face, never eat or drink in the lab because you can be consume some of the chemicals you're working with if your drink or food is contaminated with it. Another one, keep your area clean. And I would teach you how to dispose of chemicals. And here, and I just noticed this morning, that should be a 5, not a 2. I don't know how I missed that, but I do. And here's some questions. Now, for next week, what I'll ask you to do is look at the video right here, the ACS video, watch it. Next, answer the questions down here, and what you'll upload is only the questions. If you want to do the whole thing, you can, where you type in the questions, but that's all you have to do. Now, how do you upload it? You upload it as either a Word file or a PDF file. Now, what if you don't have a printer? You don't have to rewrite the questions. Just put question 1, your answer. Don't forget to put your name, 2, 3, and so on. Now, if you look at Blackboard for the assignment for a safety lab, and I also did it for the student agreement, you'll notice I have 2 documents. One is Word, the other is PDF. That's called CAM scanner. And if you don't have a regular scanner, you can use your cell phone, or some people call it smartphone. Anybody ever see a dumb phone? But anyways, you can use this to make a PDF file. It's free. Don't spend the extra money or any money to get the paid version. You just get a lot of bells and whistles you do not need. There's a free version, it works. And that will help you upload it. If you don't want to do it this way, I also have instructions, both a Word document and a PDF of how to upload a single PDF, or you can, for the test to all be PDF, but for this, a Word doc, how to do that. And you should read these if you're not familiar with it. All right, Mia, thank you. I wasn't aware of that. Mia tells us that you can use the note apps on iPhone. Thank you very much. And like I said, this lab is due by noon next week, next Tuesday. Now, a couple things about lab with safety. Safety is important. When we're face-to-face, each lab, I teach you how to handle things safely, how to use equipment safely. Remember, this is the most important piece of safety equipment. Now, another thing I should teach you, what happens if you get a chemical on your arm? The best way to deal with that is put it under cold water for about 10 minutes. And then if you need medical attention, go and get it. And a number of years ago, I had a student who didn't follow directions, and this was in an organic lab, and he got acid on his forearm. And even though I got him under cold water real quick, I was only feet away from him when he started yelling, and his lab partner yelled for help. He didn't follow directions and do something I told everybody they should do. After that, for that kind of chemicals, I always made the students either wear a lab coat or long sleeve top to protect their arms. But if you get anything on your arm, we'll rinse it off. That's something you should know. Another thing is, if you ever break any glass in a lab, ask the instructor to clean it up. I know how to do it, you don't. The other thing is, if there's ever a fire in the lab, the first thing you should do is let the instructor know. And I would be telling you this if we were face to face. If you look in the ACS video, they show you how to use a fire extinguisher, and the person doing it is doing it wrong. Always aim the fire extinguisher at the base of the fire, not on top. When I worked in industry, because I went to plants a lot, my position in the company, I and other people were given special training. It was quite exciting. It taught you to overcome your fear of fire. They'd have these big pans about this deep. It was 5 by 5 feet square, filled with gasoline. They set it on fire, gave you a hand fire extinguisher and said, put it out. And they also had pipes about 5 feet high with holes in it. They pumped gasoline. Coming out of the holes was gasoline. They set that on fire with the same fire extinguisher. You had to put that out. That really, after you did it more than once, you got over your fear of what might happen and just realized this is what I have to do. It was exciting, really. But those are things I would be teaching you. Finally, in an emergency, the most important safety piece of equipment is the phone, so you can get help. And one of the things I show in the lab is where's the safety equipment and also where's the phone. Because if something happens to me, I would tell you, call and get help for me. And luckily that's never happened. And one last thing about working in a chemical lab, whenever I go into a chemical lab, whether it's a teaching lab or a research lab in a company, the first thing I do is I look around and see how can I get out of that room if something happens. And at COD, all but one lab has 2 exits, so you can get out if one's blocked. Actually, every lab does. And that's today's lab. Now, important thing about labs, I never put any questions on the hourly exams from the lab. I keep them separate. The labs are just, the points are from your lab reports. Now I have to tell you something important, really important. This last summer, I don't know why, but I had a number of students who didn't hand in a lot of labs. I kept on emailing them and telling them, hand in your labs. I even had an amnesty. And I had at least 4 or 5 people out of 24 who missed 4 or more labs. They just never handed them in. Chat dropped their grade, what they should have got, to what they did get, a whole letter grade, which I didn't like doing, but I have to follow what's in my syllabus. So please hand in your labs on time. All right, any questions about today's lab? I'm looking at the chat box, see if anything pops up. If you have a question, turn on your mic or use chat.
I just want to go over. So we have to obviously do those questions at the end of the lab, and then we have to scan that paper and then just turn it in. Is that correct?
That's it. That's it.
Thank you very much.
Well, thank you for your question, Sergio. But my labs are not that hard. Lab is supposed to be fun, and they can be fun. Now, one other thing I do want to show you, we won't do it today, but we'll actually do it next week, and that's Beyond Lab Z. All right, if you go and look in Google for Beyond Lab Z, does everybody see Beyond Lab Z on your screen where it says continue to portal 3.0? Do you see that? No, maybe you don't. Okay, thank you, thumbs up person. All right, now, once you go to portal 3.0, this last summer, in the last couple of weeks, Beyond Lab Z used to be version 2.0, and they've converted most of it to HTML, and that's version 3.0. And once you get, when you first go to Beyond Lab Z, you'll first have to activate your access code, mine is, and then eventually you can go to this portal, which you can say, and I'm gonna log in. And this is Beyond Lab Z, the first part of it. Now, if you notice up at the top, they have web and desktop. Unfortunately, the lab we'll do next week is still on the desktop, and I'll show you how to download it and enter it. But other labs we'll be doing are here. And if you look at inorganic right here, click on chemistry, which I will. Here's the lab. Now, we'll be using this setup for 2 of our labs. But let me show you something neat. Remember, I'm a chemist. If you click on this, I put a test tube there. And let me move us over here. And you can see on the right the test tube. Now, if I want silver in there, ions, I'll click on this and notice it's silver. Now, if I want to mix it with, say, sodium chloride, everybody see this? I'll put my mouse, it becomes an eyedropper, click on that, and notice there's a chemical reaction, and there's a white solid in the test tube. Is that neat? See how easily I'm pleased? It's chemistry, I like this. And that's the sort of stuff we'll be doing here. And that's how you do Beyond Lab Z. Now, there's one thing that they put sort of hidden that I should show you. Let me get out of here. Go back. How do you log off? Ariba just asked, do we just submit the lab questions? And that's the answer, yes. If you want to do the whole doc or PDF, you can. Now, sometimes in the lab, we will have tables where you also have to put data in, and you just have to do the tables of data and the questions. Now, the safety lab, I don't have it, but for all the other labs, I have a procedure step by step what you have to do. And next week, you'll see that for the first lab, which we'll be using Beyond Lab Z. Now, the one thing I wanted to show you, if you look in the lower left-hand corner, there'll be a blue circle with a letter inside, the first letter of your login. Mine was C. If you click on that, you can see sign out, view profile, etc. And I'll click on that and I signed off. Okay, and that's how you use Beyond Lab Z. Are there any questions? That's our first lab. We're not done today because remember, I got to make up time. I just wanted to go over that first. And really, the labs I have set up this semester are a lot of fun. And if you have children and students did last spring and this summer, some of the Beyond Labs, Z labs, kids really like, even big kids. All right, no question, let's see. If you haven't gotten your access code, don't worry, let me know and I'll extend the deadline for your lab. Did you order it from the bookstore? For some reason, they're slower than molasses. For those of you who don't know, molasses is very thick substance. And if you can't, I've done where I've had students come to my office hour and I become their lab partner and Beyond Lab Z. So if you don't get the access code, let me know. All right, let's do some chemistry. Let me first close a few things. All right, let's get back to chemistry. Remember, I have the fastest mouse wheel finger this side or the other side of the Mississippi. If you ever want me to go back to a screen, ask. If you ever want me to explain something again, ask. Now, yesterday, I talked about the 4 branches of chemistry. Everybody see that on your screen right now? Thank you. All right, and you don't have to know, but let me go through it again. First of all, you should know at least be able to name one of the 4 branches of chemistry. The best is organic, but I'm an organic chemist, so I'm biased. And organic chemistry deals with, initially, eons ago, chemicals, substances that came from things that were alive. That's how it got its name, organic. But now it's been expanded to molecules that contain carbon and hydrogen. Inorganic are molecules that came from things that weren't alive, like a rock or a diamond. And physical chemistry deals with certain interactions of atoms and parts of atoms. And analytical chemistry deals with the measurement of various things. As I said yesterday, example would be all the chemists you see on CSI programs are analytical chemists because they're measuring things, doing tests to find out what is this stuff. Now, I talked about chemical, and this will never be asked on a test. It's any matter used in or produced by a chemical process, and I use it interchangeably with substance. A chemical that consists of one type of matter always has the same composition and properties wherever it's found. And like I said, I use these interchangeably. Now, I won't ask on a test, but you should know what's matter. And matter is anything that has mass and occupies space. And mass refers to the amount of matter present in a sample. Now, I have a quick question for all of you. Between now and let's say December 20th, are any of you planning on leaving the planet Earth? Okay, you're not. Either am I. And because of that, we're all going to be under the same gravity. Some chemists would argue with me, you really shouldn't do what you're going to say, Dr. White, but I will. I use mass and weight interchangeably as synonyms. Technically, they're not, because the mass of something on the Earth is the same mass on the moon, but the weights are different because of gravity. But if you're going to stay on the Earth, like all of you just told me you are going to till the end of the semester, nobody's going to go to the moon or Saturn. But anyways, weight and mass really mean the same thing. I talked about scientific, maybe I didn't talk about scientific notation that much. This switch is totally off, click. This will never be on a test, but scientists like me observe things and we collect data. And then we come up with a hypothesis to explain the data, interpret our observations. Then we run experiments to test that. And finally, we come up with a theory to explain the results. And this confirms so we can predict results from experiments. And a theory, when it's always true, becomes a law. Now, unfortunately, some people in our society don't believe in scientific method. I do. I've been using it all my life. All right, I mentioned this yesterday. Hold on. If I had a dial that I could only turn to 10, I've just turned it to 20. By the way, I stole that from the movie, This is Spinal Tap. If you haven't seen it, it's an interesting movie, very interesting. But anyways, this is something you should know. Chemical symbols, that's the elements, and we show the elements by a chemical symbol. They can either be a 1 or 2 letter abbreviation for the name of an element. And I'll be teaching you later today what's an element. Only the first letter of the element is capitalized. If there's a second letter, it's lowercase. Now, instead of having you learn the whole periodic table, I'm only asking you to learn these 37. Why? Because the rest of them I've never used, well, a few, but rarely. These I have in my daily life, and you would use them. And you should know Na is sodium, K is potassium, Mg magnesium, Hg mercury, Kr krypton. By the way, unless I've been kidnapped to another universe, in our universe, krypton is a colorless gas. It's not a green solid that kills Superman. And its chemical symbol is Kr. And what do I mean? You should know this on a test. If I ask, give the chemical symbol for helium, you should know that. First of all, I got to turn on my pad. It's on. You should know helium, the chemical symbol is He. For gold, it's Au. And that's a question I can ask. Given the name, write the chemical symbol. I can also ask, give the symbol, write the name. Ag is silver. Ooh, that reminds me. A couple of years ago, and I'm gonna also do a generation gap, I pulled up to a stoplight. In front of me, I looked at the license plate of the car in front, and I saw this. And the license plate was HIHOAG. I'm thinking there, and it took me about almost 3 seconds. I started laughing. I said, that person's cool. And that's Hi-Ho Silver. And for those of you who grew up like me in the Lone Ranger, not the Johnny Depp movie, oh, it's disgusting. Go back and look at Clayton Moore, Lone Ranger. Great. And every Lone Ranger started out Hi-Ho Silver. By the way, Silver was the name of his horse. Great memories from my childhood. Anyways, you should know these elements. Example, U is uranium, C is copper, O is oxygen, N is nitrogen. So there are two questions I can ask. Here's the symbol, here's the name of the element, give its symbol. Here's the symbol, give its name. Now I want to ask you about license plate numbers. All right, now when we talk about matter, oh, look, Dr. White's being subtle. Everybody see that at the bottom? And know this. When we talk about matter, there are three physical states of matter. You probably have heard of these, but let's go through it. The first one is a solid. And you should know a solid has definite shape and definite volume. I just happen to have a solid. And if you notice, this plastic has a definite shape and definite volume. If you come back tomorrow, it's going to be the same thing. It's a solid. And you should know solids have definite shape, definite volume. Now, a liquid has indefinite shape, but definite volume. What's indefinite shape? Well, I just happen to have in this bottle a liquid. We call it water. And notice how the water takes the shape of the bottle. If I were to pour this into a round glass, the water would then take the shape of that glass. And by the way, if anybody ever sees any square glasses, let me know. I haven't looked for a while. That would be cool to have. If you had a square glass, you poured a liquid in there, it would take the shape of that container. And that's what we mean by indefinite shape. But if I have so much volume amount of the liquid, you know how you measure in a measuring cup, a quart or an ounce, or in chemistry we use, I'll teach you later, milliliters. And when this was full, it had 700 milliliters. I reuse my bottles. That's the volume, and that won't change. The shape will, but not the volume. And finally, a gas. And a gas has indefinite shape and indefinite volume. And what that means is if I in my room, or if you were in a room and somebody opened up a container with gas, it would fill the whole room and it would expand to the volume of that room. And if you had a larger room, it would expand to a larger volume. So if we were in face-to-face, I'd say, all right, everybody together with me. Let's say the three shapes of matter, three physical states of matter. And the first one is solid, but since you're not, I'll do it for you. Second one is liquid, and the last one is gas. At this point, I'd say to everybody, all right, come on, let's do it with feeling. Let's do it again. Three states of matter are solid, liquid, gas. And you should know, hint, it even says it on the slide, solid has definite shape and definite volume. Liquid has indefinite shape and definite volume. And a gas has indefinite shape, indefinite volume. Do you realize you're surrounded by a gas? We call that air. And like I said, this is a liquid. And this has definite shape and definite volume. My stylus for my writing tablet, that's a solid. So remember the three states of matter: solid, liquid, gas. Now, when we talk about matter, there are two types. One is called pure substances, the other mixtures. Again, there are two types: pure substances and mixtures. And when we talk about a pure substance, that I will never ask what is a pure substance, but is a type of matter that has a fixed or definite composition, composed of one type of atoms or molecules. I'll teach you later on this semester what's an atom or a molecule. But what that really means, and by the way, I'll slow down, anybody who's writing this down. Remember, all my slides you're seeing now that I've typed are in a files in the lecture folder of Blackboard. This one is secretly named Chapter 1. All right, now, when we talk about pure substances, what you really should know, there are two types. One are the elements, and the other are compounds. So when we talk about pure substances, one is the elements and the other are compounds. Now, what are the elements? The elements are pure substance that contains only one type of atom. Again, I won't ask you what is an element on a test. And also it's a pure substance that can't be broken down into simpler substances by chemical or physical means. That's an element. Now, what you should know, what are examples of elements? And before we do that, it's time for a commercial from Dr. White. Please start learning the chemical symbols. Remember, the chemical symbols are one or two lettered abbreviations for the name of the elements. Only the first letter is capitalized. If there's a second letter, it's lowercase. And I've only asked you to learn these 37. Know them. Practice them now. Don't wait until a day or two before test number 1. Let's look at, something. One of the things on Tuesdays when we go more than 50 minutes, we take a break, because having taught enough and also lectured enough at conferences, if you go more than 50 minutes, people sitting, their brain shuts down, which doesn't help you learn things. So let's take a 5-minute break, come back at 9:55, and we'll continue on. So take a 5-minute break. I can get up and stretch, and I'll see you in 5 minutes. Be right back in 5. Time to get going. All right, everybody back. Welcome back. First of all, a quick commercial, real commercial from Dr. White, me. Does everybody see Chem 1105 YouTube on your screen? And you can see the first lecture from yesterday is up there. Who's that handsome guy? Right. Good morning, everybody. Welcome to a wonderful semester and a wonderful. And again, here's this link. The URL is both in the syllabus for this and also in Blackboard. If you look in the left, you can click on an entry for YouTube. That'll show you the link to this. By sometime late this afternoon, if not earlier, today's lecture will be there too. But you still should come to lecture, but in case you miss, you can look and see what you missed, or if you want to see something again, you can play it again. All right, now we're talking about elements, and one of the things I haven't done, which I should do right now, if I can find where I have it hidden. Huh. All right, well, let's get it the other way. It happens every once in a while where all right, well, I don't have it. I'll have to show you tomorrow the periodic table we use with this class. I've got it on my other computer. I thought I had it on this one. But anyways, here's another periodic table. If you look on your screen right now, you'll see the dynamic periodic table. And on the one you'll be using for the test, not this one, you won't have the names of different elements. But if you notice over here, C is carbon. Let me minimize. And you can see over here, it shows you O is oxygen. And you should know Ni is nickel, Na is sodium. And this is one neat periodic table. It's called the dynamic periodic table. If you don't have that, ever seen it, check it out. It's a lot of fun. All these are elements, and each element is a pure substance. So if I were asked on a test, give an example of an element, you could do any of these. If I ask, give an example of a pure substance, well, you could put down sodium, potassium, hydrogen, magnesium, calcium. Those are all pure substances. So is gold and silver. Now, the other type of pure substance are called compounds. And a compound is a pure substance consisting of a combination of two or more elements always in the same ratio. And it's a pure substance that can be broken down into two or more simpler substances by chemical means. All right, time for me to teach you something important. How do we show a compound? Use the chemical symbols to show what it's called the empirical formula, chemical formula. That's water. And the empirical formula tells you what type of elements are involved in that compound and how many. And notice here to the right subscript of hydrogen is 2. So that means there's 2 hydrogens plus when there's nothing there, 1 oxygen. That means there's 3 atoms in water. And this is water. And hopefully, if you don't know, you now know H2O is the chemical symbol for water. Now, most of you have probably used this substance before. NaCl, 1 sodium, 1 chlorine. How many atoms are in there? 2 atoms. And you call this either salt or table salt. And that's the stuff you put on your French fries and other things. At least I like salt. Now, true story. If you ever go out to lunch, breakfast, lunch, or dinner with a bunch of chemists, especially with me, one of us, and I've been guilty of it many times, I'll say to someone, could you please pass the NaCl? NaCl? That's a chemistry inside joke for chemists. By the way, you can moan and groan and boo at my bad humor. It's allowed. Now, there's something else. When we have what's called a polyatomic ion, like this, the question is, how many atoms are in this molecule? It's called calcium hydroxide. Now, here, there's 1 calcium. Now, when you have the brackets, like I have here, you multiply everything inside times the number to the right in subscript. So 2 times 1 is 2 oxygen, 2 times 1 hydrogen, 2 hydrogen. That means there's 5 atoms in calcium hydroxide. Hopefully everybody knows the abbreviation PTS is points. All right, it's time for me to share the fun. And why don't you answer the first one? How many atoms are in magnesium chloride? A, right here. Your turn to have some fun. See, Dr. White's really nice. I like to share the fun. I'm not going to hog it all to myself. I see people are already answering. Thank you. And one of the things I like to do is give everybody time. Let's try this. Sometimes I'll give a thumbs up, or I'll take a poll like now. Are you done? And it looks like everybody's done. So let's do it. It has 1 magnesium, and 2 chlorines. So that's 1 plus 2 equals 3. So they're 3 separate atoms, 2 chlorine, 1 magnesium, magnesium chloride. Ooh, this is an interesting one for you to do. And have fun with it. How many atoms are in B? See, a number of people are answering. Let's. Thank you. I think everybody's done. So let's do this. It has 1 calcium, Ca is calcium. Now it has 1 hydrogen, but it's in a bracket too. So there's 2 hydrogen. There's 1 carbon, but it's in a bracket with 2. There's 2 carbon. C is carbon. O, oxygen, there are 3, but it's in a bracket where you have 2. 2 times 3 is 6. I add it together, I get 11. And that's how many atoms are in calcium bicarbonate. Ooh, let's try one more. Sodium hydroxide. How many atoms are in this molecule? Ready, set, go. Not that this is a race. All right, I think everybody's done, so I better get to work. There's 1 sodium, Na is sodium, O is oxygen, there's 1, and there's 1 hydrogen. So if I add it all together, it's 3. Remember, if I ever make a mistake and if I put down 8, I hope all of you should say, Dr. White, you made a mistake. It's not 8, it's 3. And that's something you should know. And these are all compounds. Sodium hydroxide is a very important compound in the United States and the world. It's heavily used to make many things, including your bar soap. Ooh, I forgot to do something. Time out for a real public service announcement from Dr. White. Numbered a long time ago, I worked as the research section head or research manager section head of process and product development for a certain group of compounds for this international chemical company. And I was responsible for all of North America. And the chemicals I was responsible, a number of them are additives in gasoline. And because of that, I got to know and go out and talk to companies that make gasoline, petroleum companies like Shell, Mobil. Back then it was called Standard, now BP. And by talking to the people at their research center, when I was trying to sell our chemicals to them, I found out, and most of them agreed, what's the best gasoline? What's the worst? The best gasoline, and today it still is Shell. And this will never be on a test, but I thought I'd share this with you. Mobil is almost as good. And this is both the purity and the additives that help your car run better. The worst gasoline back in the 1980s, and it's still the worst. Back then it was called Standard, now it's BP. And if you don't believe me, go look on Google. About 3 or 4 years ago in the Hammond, Indiana, Illinois area, foundry, not foundry, BP petroleum site, distillery, was making gasoline to be sold in that area. And they did such a poor job. They messed it up how, I don't know. You got to really be but anyways, they were that they destroyed the engines of over 3,000 cars from the bad gasoline they sold. And for that alone, and I already knew before them, they were never considered well by the rest of the people, good by the rest of the people in the industry. I will never put BP gasoline in my car. I have a Ford Explorer. I've had a couple of Ford Explorers. I like them. I like SUVs. Now, here's an important tip. One, to make your engine run better, unless you have a Ferrari or Lamborghini, most of the time use the lowest quality, lowest octane gas. But about once every 3 months, I let my gas go down to about a quarter tank. Normally, I don't let it go down to less than a half, but that's my own personal preference. I don't have to worry about running out in a snowstorm, which almost happened one time years ago. I was stuck on the Dan Ryan. It took me almost 3.5 hours to get home. It was close. So that's a personal thing. But I let it go down to a quarter. I do this about 3 or 4 times a year, and I fill it up with the most expensive. And I always do that with Shell because it's the best. The more expensive gasoline has better additives, and you only have to do it every once in a while. That helps keep your engine clean and running well. Now, one other thing I want to show you, again, this won't be on a test. I gotta find it. I have it bookmarked on my other machine. Oh, here it is. All right, everybody see Gas Buddy on your screen? The actual URL is chicagogasprices.com. And this is a great site. I've been using it for years. And it gives you the gas prices of gas stations in a certain zip code. If we are looking at Glen Ellen area, here are the different prices. If you notice, they're quite different. You look at the Shell on Roosevelt and Park, which is right by COD, is $3.14 a gallon. This is a price 11 minutes ago. If you look over by Butterfield and I-53, it's a lot more. And you can save a lot of money during the year by checking different areas. I also teach at Elgin Community College. That's that zip code. And notice the price differential here is a lot higher, except there's some right down here that are lower. So this helps you. Usually I go, when I go to that school, which I haven't, I go to this Shell station, which is quite high today, and I wouldn't buy from them. I'll buy them by my house, which is a little cheaper. Or if I was at COD, I'd go to that Shell on Roosevelt. So if you need this website address, email me and I'll always feel free to send it to you. But it helps you save money, because sometimes the price of gasoline in a certain area, one gas station for another, can be as much as 20 cents a gallon. 10 gallons, that's $2 you just saved by looking this up. All right, so you learned about compounds. And if I were to ask you, give an example of a compound on a test, you could put down water. That's a compound. Sodium chloride, NaCl, please pass the NaCl. Oh, another one. That's calcium chloride. How many of you are familiar with the little round pellets you buy to put on your sidewalk in the winter to melt ice when it's super cold. And those little pellets are this compound, calcium chloride, 1 calcium, 2 chloride ions. Now, we have pure substances, and then we have mixtures. And mixtures are, you should know, are 2 or more substances that are physically but not chemically combined. What do I mean by that? That means you can separate them. They don't react with each other. And let's look at, before I go on to the next type, what would be an example of a mixture? I've got water in here. If I were to put salt in there and shake it up real good, I'd have a mixture of salt and water. I could do the same thing with sugar, make it sweeter instead of salty, put sugar in here, water, mix it up. And if I took the water away, the sugar would remain. And neither react, they both retain their own chemical identity. And we call that a mixture. Ooh, not to scare you, but I will. Are you all breathing right now? I hope you are. The air you're breathing is a mixture. It's a mixture of oxygen, O2, and nitrogen, N2 molecules. And the oxygen is keeping you alive. And the nitrogen's there also to help, what we'll teach you later, the pressure. So that keeps you alive. Ah, Spencer, thank you. There's a Gas Buddy mobile app. Generally, I'm use the computer at home. The only time I use my cell phone, I guess old generation, is for phone calls and text messages. Now, when we talk about mixtures, by the way, click the switches on. There are 2 types of mixtures. One is homogeneous mixture, and the other is heterogeneous. And homo means the same, hetero means different. And a homogeneous mixture, I won't ask you the definition, but you should know examples. The composition is uniform throughout the sample. And later on, it's also called, I'll teach you, a solution. And what's an example of a homogeneous mixture? Well, if I take water and sugar, shake it up, it will be the same throughout. I'd have a mixture of water and sugar. I could do the same thing with salt and water, and it would be the same composition throughout, mixture of water and salt. So that would be homogeneous, the same throughout the mixture. Now, the other type is heterogeneous, and the composition is not uniform throughout the sample. And you should know what are examples of heterogeneous mixtures. Well, one would be, how many of you have ever seen an oil vinaigrette dressing? You shake it up, put it on your salad, then put the bottle down, all of a sudden you see 2 layers. One layer is the oil, vegetable oil or olive oil, and the vinaigrette is mainly water, and you see 2 separate layers. Not that I'm going to do it, but if I were to dump a handful of sand in this bottle and shake it up and then let it rest, you'll see all the sand float to the bottom. It won't be the same throughout, and that would be a heterogeneous mixture. Now, another example, and please do not try this at home, gasoline and water don't mix. If you were to shake it up, it would separate just like an oil vinaigrette dressing, but don't try this at home. And that would be a heterogeneous. So homogeneous, the same throughout. An example of that would be, say, a sugar solution or sugar and water or salt and water. And another example would be, I don't have any, I ran out, but my tea would be a homogeneous solution. Coffee, Dr. White has had 5 cups of coffee in my life, and that's 5 too many. I just don't like the taste of it. My father didn't either. My sisters and mother loved it. I just don't, I'm not a coffee person. But anyways, coffee is a homogeneous solution. And like I said, so is the air. Now, heterogeneous, oil vinaigrette, sand and water, and other things like that that separate. Now, when we talk about matters, there's certain properties of matter that are important to know about. And these, I'll never ask you what's a property of matter, but these are characteristics that distinguish one substance from another. When we talk about that, there are 2 types of properties. One is called physical property. And a physical property is a characteristic of a substance that can be observed without changing the basic substance identity of the substance. Another way is our physical properties are distinguishing characteristics of a substance that are used in its identification and description. So what would be a physical property? Well, is that chemical what color? White, red, yellow? That would be a physical property. Does that chemical smell nice or not? When you smell a flower, I hope you like the things like a smell of a rose, you're smelling the physical property of a chemical that the flower emits to attract bees. Now I'm way beyond my knowledge of botany. And those would be physical properties. I just remembered something. Years ago, I was teaching general chemistry at another school. I was community college, and one of the students came in, and this was face to face, and said, "Oh, look at my new ring. I just got engaged, and it was a beautiful ring, and it wasn't gold." She said, "Oh, I'm so proud. My fiance got me a platinum ring." And about 3 weeks later, she comes to me in private and says, "Can you help me, Dr. White?" And I said, "Well, I'll try. What's wrong?" So look at my new ring. It's getting scratched on the bottom. I said, "Well, that's because of the physical property of platinum. It's a soft metal and it can scratch. Gold, like my ring here, and this sucker is I've had for many decades. There's no scratches at all on here. It's a much harder metal. And that's a physical property of gold versus platinum. So word to wise is don't spend the extra money on platinum, get gold. Oh, by the way, I'm not associated with any jewelers yet, so I don't get any kickbacks for saying that. Now, examples of physical property. If I were to say, if we were at COD, I'd say, look out in the parking lot and how many cars are red or blue or yellow. And that's a physical property. The boiling point, the temperature at which something boils, and I'll teach you about boiling points and melting points, the temperature at which something melts, like ice melts at 0 degrees Fahrenheit or Celsius, 32 Fahrenheit, those are physical properties you should know. Now, there's another we call a chemical property. And a chemical property is a characteristic of a substance that describes the ability of that substance to change into new substances. In other words, how reactive something is. I'll never ask you what is a chemical property, but I will ask you, some examples. Give an example on a test. I give an example of a chemical property. An example would be, if you had a regular car, it could rust. In other words, the metal on the car reacts with oxygen to form rust, another chemical. Now, for those of you who've seen Back to the Future, the DeLorean they don't make them anymore, the only car I know of that was stainless steel. And stainless steel will not rust under normal conditions like regular steel will. And that's a chemical property. If something is flammable, this is water. A chemical property of water is it doesn't burn. We use this to put out fires, the firemen do. However, and do not try this at home, gasoline will burn, and piece of paper, it will burn. That's a chemical property of paper, which is a chemical substance. Actually, it's more complex than that nowadays. And by the way, hair is very flammable, so be careful around flames if you have long hair. We teach that in the lab. Keep your hair tied back. You'll see that in the video. But anyways, those are all chemical properties. So if I ask you, give an example of a chemical property, you could put down gasoline burns. Steel, that's not stainless steel, can rust. And those are two examples. Ooh. Next time you see a candle burning, the wax burns to form the flame in the wick, because that's the chemical property of the wax. And I worked for a chemical company, Unichem, that got its start about, when was that? About 1750, yeah, that long ago, 1780, in the Netherlands, by taking animal fat and making them into one of the chemicals used in candles, which they then make candles. And when I was working there, I happened to be, well, I think it was the 150th or whatever anniversary. I happened to be in the Netherlands for that. Well, by the way, chemists know how to party real hard. We keep that a secret though. We had a good time. Everybody got handmade special commemorative candles and a candle holder made of Delft Blauw. If you don't know what Delft Blauw means, that's Delft is a city, Blauw is blue. That's traditional pottery from, oh, what the heck, let me show you. Does everybody see the tiles on the screen? By the way, I have a collection of my own that are better than these, but they're nice. And this is Delft Blauw. And by the way, if you've never seen windmills, you're missing a lot in the Netherlands. Windmills, most Americans will see with the wood here, right here, they also have a sail on it and they turn, and that provided windmills were originally used as pumps to reclaim land from the sea to pump the water out. Most of the Netherlands, a good part of it is under sea level. Oh, quick tip. If you haven't been to Amsterdam, go. I haven't been there in a long time, but I used to go a lot. And when I went there, I'd always, in Europe or Netherlands, I'd always be able to manage to arrive at Amsterdam Friday afternoon and fly out back to Chicagoland, O'Hare, Sunday morning. So I had a couple of days to chill out in Amsterdam. And I came up with a saying, you know what it means if you're not having a good time in Amsterdam? You're dead. You always have a good time in Amsterdam. Now, we also have what's called changes in matter. And you should know there are two types of changes in matter. One is a physical change, the other is a chemical change. Now, what is a physical change? A physical change is the process in which a substance changes its physical appearance, but not its chemical appearance. In other words, it goes from one state of matter to another. An example of a physical change you should know is when ice melts. Ice, which is solid water, goes from a solid ice to a liquid. That's a physical change. And I would ask, how many of you, whoa, let me get that. How many of you have boiled water? Hopefully all of you have. And what's happening when you boil water? It's a physical change. Water is going from a liquid to a gas. That's what boiling is. And if you were to, how many of you have ever seen in the winter when you boil water in the kitchen, if you have a window nearby and it's real cold out, you see the steam go on the window and condense to sort of like a liquid on there, covers the window. It's going from a gas back to a liquid on your window. But you never knew when you boiled water and things like that, you were doing chemistry. I'll teach you more about what is boiling water. Now, the other type of change is a chemical change. And that's when an original substance is converted to new substance that has different composition, new chemical and physical properties. In other words, you made a new compound. And a chemical change, what are examples of that? Now, if you have a butane lighter or any kind of lighter, and you light it and the flame comes out, I should mention, most good organic chemists, when they were young, were pyromaniacs. We love to burn things. I've talked to a lot of organic chemists who I know who are good. We all have the same experience when we were little. We burn things. And if you light a lighter, the flame, or light a candle, it's undergoing the wax or the butane, like in a butane lighter, is undergoing a chemical change. Now, not to scare you, but I will. When you chew your food and swallow it and it goes in your stomach, your food is undergoing a chemical change when it's being broken down to simpler things for your body to use for whatever your body uses it for. So next time you're eating and you swallow that food, remember, in your stomach, that food is undergoing a chemical change. It's being converted into other chemicals that your body needs. I don't know if I mentioned this, I should. Last time I took biology was my freshman year of high school. Wow, that was a long time ago. Nothing wrong with biology, but by then I already knew I wanted to be a chemist. Now, in the book, we have something called temperature, and this is a good time to talk about it. I'll never ask you what is the temperature or something, but it's a measure of how hot or cold a substance is compared to another substance. And heat flows from a substance of higher temperature to a substance of lower temperature, which is how you get burned. You touch something hot, energy, heat is going into your skin and doing damage. Don't touch anything hot, please don't. Now, there are three temperature scales. The first one we use in science, one of them is Celsius. Celsius is abbreviated by usually the superscript circle C, degrees C, or DEGC. Now, once in a while, when I first learned this until, I don't know, 1980s, it used to be called centigrade, and once in a while, I'll say that. It still pops out. Another scale chemists use, and we'll use this semester, is Kelvin. Now, you don't say degrees Kelvin because Kelvin is an absolute scale as opposed to Celsius, which is relative, which is why we use degrees. And it's abbreviated by K. And this is named after Lord Kelvin, a great English chemist. And finally, the one you're most familiar with here in the United States is Fahrenheit. And that's degrees F, which is 0 superscript 0F or just DEGF. Now, there are formulas for converting from one scale to other. And notice at the bottom, know how to use these conversion formulas for temperature. It's time now for me to explain something important. About 2 years ago, I was having a discussion with another faculty member who I respected, COD. We're talking about teaching and general chemistry, and he had just changed something important in his class and convinced me to do the same. In the past, those formulas, I'd be telling you now, you better start memorizing them because you have to use them on the test. Except at that point, the chemistry instructor challenged me and said, are you testing students' knowledge of chemistry? Or are you also testing how good their memory is? And I said, I really should be testing how good they learn chemistry, not how good their memory is. And because of that, I changed my philosophy. And what did I change? Instead of having you memorize a lot of formulas, I give them to you on the test in what's called important information. And if you go to the lecture section, and I don't have it up, but I'll open it up. And test one, everybody see important information, test one on your screen? Thank you. You'll see I give you these formulas. I also give you other information I'll talk about later this coming weeks. And you no longer have to memorize these, but you will know how to use them, learn how to use those. And if I look at the clock, I think we made a good headway in today. And guess what? I'm going to call it a day. I've covered a lot, so we can not lose the time that we will when Labor Day and other holidays come up. And with that, I'm going to say, Gehen gesund. Remember, that's Yiddish for go in health or be healthy. I'm done. Bye then. And I'll see you tomorrow. Remember, tomorrow we have lecture at 10 a.m. Show up on time, please, and we'll continue with the lecture. If you have any questions, I'll stick around for a little while. Later today, today's lecture and lab will be on YouTube. And with that, Gehen gesund. Goodbye.